half angle formulas. Here's some half angle formulas here, okay? Memorize those. Notice that the sine of pi alpha over 2 and the cosine alpha over 2 are the same, except what? The sign between the 1 and the cosine changes, okay? And we have three forms of tangent of pi over 2. Now, how do you know whether to use the plus or the minus sign? Well, that's going to be determined by the quadrant in which pi over 2 lies in, okay? All right, before I do this example, let's actually do one. It's not even in our notes, but let's just do one like, say, sine of 15 degrees so we can get a good handle on this. All right, a sine of 15 degrees. I don't know what that is, the exact value of it. So what I do is I look at this as, well, that's the sine of 1/2 of 30 degrees, because 1/2 of 30 is 15. All right, then I could say that's the same thing as the sine of 30 degrees over 2. Now it's really in this form right here, alpha over 2. Alpha happens to be 30 degrees. So what I do to find this is I use this formula right here. I'm going to say we're equal to plus or minus the square root of 1 minus the cosine of alpha. But what is alpha in this case? 30 degrees all over 2. All right, now, how do I decide if it's positive or negative? Look at what I originally had, 15 degrees. Where's 15 degrees at? That's in quadrant number 1. My sign is positive in quadrant 1. So it's going to be a positive 1 minus cosine of 30 degrees over 2. But what's the cosine of 30 degrees? We memorized that for the unit circle. What do we memorize that to be? Square root of 3 over 2? Now, I don't like having fractions on top of fractions here. So I'm going to do this. I'm going to say, okay, let's rewrite this. So in other words, we're just copying it over. And let's multiply the top and the bottom by 2. And what does that give me? That gives me a square root of 2 minus square root of 3 all over 4, right? So that gives us square root of 2 minus square root of 3 over, what's the square root of 4? Just 2. There we go. There's my exact value, the sine of 15 degrees. All right, that one was not in the notes. I just wanted to show y'all how this stuff is used. All right, let's get to our next example in the notes. This example says, use the half angle formula to find the exact value of the cosine of 7 pi over 12. All right, so if I'm using a half angle formula, I'm going to say 1/2 of something gives me that 7 pi over 12. 1/2 of what? 7 pi over 6 will give me that, right? And another way to write this is I can write as the cosine of 7 pi over 6 all over 2. Now it's in the form alpha over 2, cosine of alpha over 2. Alpha is 7 pi over 6. So it's in this form, right? So I'm going to use this formula to find a value. I'm going to use plus or minus the square root of, what's that formula tell me? 1 plus the cosine of alpha. And what's alpha again? 7 pi over 6 all over 2, according to the formula. All right, let's see. Is this thing going to be positive or a negative? Think of 7 pi over 12. All right. Think about a coordinate plane. Isn't this pi over 2? Isn't that pi? So if I multiply the top and the bottom of this by 6, won't that be 6 pi over 12? Yeah. So where does 7 pi over 12 lie? Between 6 pi over 12 and between pi. So we're in quadrant number 2. So what is my cosine in quadrant number 2? It's negative. So I'm going to use negative. Square root of 1 plus the cosine of that over 2. Let's find our cosine of 7 pi over 6. Where is 7 pi over 6? 7 pi over 6, it's like right here, right? This angle? Oh, no. I'm in the wrong quadrant here. Let me keep going. Where's 7 pi over 6? Right here, right? What reference angle goes right here? Pi over 6, right? So where am I at on the unit circle? If I think about the unit circle, where am I at if I'm in a reference angle of pi over 6? Where does that put me? Square root of 3 over 2, comma, 1/2. And what's negative in quadrant number 3? X or Y? Well, actually, both of them, right? All right, so what is my cosine at 7 pi over 6? It's negative square root of 3 over 2. So I'm going to put negative square root of 3 over 2 right here. Well, that'll be negative square roots of 1 minus square root of 3 over 2 all over 2. Now again, I do not like having fractions over fractions, so I'm going to multiply by the least common denominator up top, which is 2. So I'm going to multiply the top and the bottom by 2. Alright, so I still have a negative sign. I'm going to have the square root of, if I distribute 2, I get 2 minus square root of 3 all over 4, right? Well, that's negative. The top stays under a radical. 2 minus square root of 3. How about the bottom? What's square root of 4? Square root of 4 is 2. There's my exact value of the cosine of 7 pi over 12. Now, if I can only find where I put my notes at so I can get to my next example here. Hey, found them. What do you know? Part B. Part B has the same directions. Use the half angle formula to find the exact value. And for part B, I'm going to have a tangent one. It's going to be the tangent of 7 pi over 8. B is going to be the tangent of 7 pi over 8. All right, so if I'm using a half angle identity or half angle formula here, what am I going to do? I'm going to say this is the same thing as the tangent of 1/2 times some value gives me 7 pi over 8. Well, 1/2 times what gives me 7 pi over 8? 7 pi over 4, right? So let's do a rewrite and let's call this the tangent of 7 pi over 4 over 2. Isn't dividing by 2 the same thing as multiplying by 1/2? All right, this is in the form alpha over 2, where alpha is 7 pi over 4. So the tangent of alpha over 2, I have a choice here. I could use this formula, or that formula, okay? It's my choice. I choose not to use this formula because if I use one of these two, I don't have to deal with that plus or minus stuff and figure that out. I'm going to use the bottom one maybe, okay? So the bottom formula is the sine of alpha. What is alpha in this case? 7 pi over 4 over what? 1 plus the cosine of alpha. What is alpha again? 7 pi over 4. Well, let's do some math here, okay? What's 7 pi over 4? 1 3/4 of a pi? So 1 3/4 of a pi puts us here, right? What is my reference angle associated with that? Pi over 4. So where am I at on the unit circle with a reference angle of pi over 4? Square root of 2 over 2, square root of 2 over 2. But in quadrant number 4, what's negative? My x or my y? My y. So let's see, what is the sine of 7 pi over 4? That would be negative square root of 2 over 2. over 1 plus, what is the cosine of 7 pi over 4? Cosine is square root of 2 over 2. Again, I don't like fractions over fractions, so what am I going to do? I'm going to say, okay, square root of 2 over 2 over 1 plus square root of 2 over 2. If I multiply the top and the bottom by 2, that should get rid of my fractions. Let's see. I get negative square root of 2 is my numerator. My denominator, I get 2 plus square root of 2, right? Well, I still need to rationalize my denominator here. So what am I going to do? I'm going to multiply by the conjugate of my denominator, 2 minus square root of 2. Top and bottom, I'm going to multiply by the conjugate. So what does that give me? That gives me negative 2 square roots of 2 plus 2 all over 4 minus 2, right? Remember, when you multiply in a binomial times its conjugate, the outer and the inner terms zero out. So all I really need to multiply is first and last. All right, let's see what that gives me. Negative 2 square roots of 2 plus 2 over 2, right? Well, I could write this as negative 2 square roots of 2 over 2 plus 2 over 2. Negative 2 square roots of 2 over 2 plus 2 over 2. Well, what does that give me? Negative square root of 2 plus 1. Not pretty, but guess what? It's their exact value. Let's look at what we have next. Next, we're going to an example, and it reads something like, find the exact value of sine of alpha over 2, and it gives us conditions here, right? It says what I want to find is the sine of alpha over 2 if what? Cosine of alpha is equal to 12 over 13. And then they say alpha is going to fall between 3 pi over 2 and 2 pi. Oh, how sweet. They give us a quadrant that falls in. So if they give us a quadrant that falls in, let's draw a picture of that, okay? All right, 3 pi over 2 is here. 2 pi is here. Maybe I'll look at some angle like that, okay? All right, I'm going to look at this reference angle here, alpha prime, and I'm going to make a 90-degree angle right here, okay? And if the cosine of alpha is 12 over 13, cosine of alpha prime is the same thing. So right here, the cosine is going to be 12 over 13. So that means adjacent over hypotenuse is 12 over 13. So I'm going to draw 12. I'm going to draw 13. All right, let me just erase this for now. It's getting a little cluttered here. Let me find a sine of alpha over 2. According to my identity, it's going to be this, right? It's going to be plus or minus the square root of 1 minus cosine of alpha, 1 minus cosine of alpha over 2. All right, let's see. It's going to be plus or minus the square root of 1 minus, what's the cosine of alpha? They give me that. They give me that's 12 over 13 all over 2, right? Well, let's see. That's plus or minus. I'll deal with the plus or minus in a minute, okay? 1 minus 12 over 13 over 2. I do not like how that's written. I do not like fractions inside of fractions. So I'll multiply by 13 over 13, and then we get plus or minus the square root of 13 minus 12 over 26, right? Well, what's 13 minus 12? That'll be 1, right? All right, so what is this? This is plus or minus the square root of 1 over square root of 26, I could think of it. Remember if you have a quotient like this, you could take the square root of numerator over the square root of my denominator. Well, that's plus or minus square root of 1 is 1. Square root of 26 I cannot take, so I leave that as the square root of 26. Well, again, I need to rationalize. So let's multiply by the square root of 26 over square root of 26. So that gives me square root of 26 up top. That gives me 26 down below. All right, so what is this answer going to be? Is it going to be the positive or the negative? What does this tell me? The positive or negative is determined by the quadrant which pi over 2 lies. Or alpha over 2, I'm sorry, lies. Where is alpha? This is alpha right here, right? Alpha's in quadrant 4, the terminal side. So where is alpha over 2? Let's think about this for a second, okay? If alpha is over here in quadrant number 4, it's between 3 pi over 2 and 2 pi, right? So alpha is between what? 3 pi over 2 and 2 pi, right? So where would alpha over 2 be between? Alpha over 2 is half, right? So what is half of this angle right here, okay? If it's between 3 pi over 2 and 2 pi, half of it would be like between half of this stuff. So it'd be 3 pi over 4 and 1 pi, right? So wouldn't that make that in quadrant number 2? What is the value of my sine function in quadrant 2? It's going to be positive. So my answer would be square root of 26 over 26. Positive. All right, our last example, part A and part B, okay? Let's look at it. Find the exact value. You always want the exact stuff. Well, let's see. How can we find exact values? All right, we have cosine of 1/2 of the arc sine of 3/8. They want us to find the exact value of this, okay? What does arc sine mean again? The angle whose sine, right? The angle whose sine, the angle. So really I'm looking at 1/2 of an angle, right? Really looking at 1/2 of an angle here. So I'm going to say let's let alpha equal to that angle, the arc sine of 3/8. So what does that mean? That means I could take this and I could transform it into the cosine of 1/2 alpha, right? What does that tip me off to? Cosine of 1/2 alpha is the same thing as cosine of alpha over 2, which looks a lot like this right here, right? So I'm going to use this formula. I'm going to say, okay, this is plus or minus the square root of what? 1 plus the cosine of alpha over 2. Now I need to fill in there, determine this, and I'm done, right? Let's see how we can do that. Let's look at what we did here. Alpha is the arc sine of 3/8. So alpha is the angle whose sine is 3/8. Remember, for the arc sine, I want to be between what? Negative pi over 2 and pi over 2. Well, if that angle is positive, I'm going to be in quadrant 1 here, okay? Let me draw a triangle here, right triangle. And I'm going to call this angle alpha right here, okay? Alpha is the angle whose sine is 3/8. So the sine or opposite over hypotenuse is going to be 3/8. All right, now just to speed things up here, okay? If you use the Pythagorean theorem, you get square root of 55 here. I don't think I need to show y'all that again. I'm just bored now showing y'all that again. All right, well, let's see. I'm looking technically for the cosine of something, right? And if we're in quadrant 1, the cosine is going to be what? Positive. And I'm going to say this is positive square root of 1 plus the cosine of alpha. What is the cosine of alpha? Square root of 55 over what? 8. Square root of 55 over 8 all over 2. Well, again, we got those nasty fractions inside of fractions, so let's multiply top and bottom here by 8. So we get the square root of 1 plus the square root of 55 over 8 over 2. Let's multiply by 8 over 8. And what do we get here? We get the square root of 8 plus the square root of 55 all over 16. Well, that's the square root of 8 plus the square root of 55 over square root of 16 happens to be what? 4. There we go. Not very pretty again, but guess what? It's the exact value. Let's do part B here. Part B. All right, for part B, we have the tangent of, go ahead and write brackets this time. Tangent of 2 arc sine of negative 1/3 of negative 1/3. All right, so what do I have here? 2 times some angle, right? Isn't the arc sine the angle whose sine? So I'm going to say, let's let alpha, theta, whatever Greek letter you want to use, equal to arc sine of negative 1/3. So in other words, this becomes what? The tangent of 2 times theta. If I let this stuff be theta, right? 2 times theta. 2 times something. I do not have that identity here, right? So that's what? That's 2 times an angle. So that's a double angle formula, or double angle identity, whatever you want to call it. All right, what was my double angle identity for tangent? We had tangent of 2 theta. What was that equal to? 2 times tangent of theta over 1 plus tangent of theta squared. Go back. Look at your notes there. You should have that one. Make sure you got that one down. All right, so how in the world now are we going to use it? Actually, let me write it correctly so I can use it. That should be a minus there. That should be a minus. So how could I use that? Well, what does that tell me? It's 2 times tangent of theta over 1 minus tangent of theta squared, right? All right, let's calculate. I need to know what the tangent of theta is so I can sub in that value here. Well, what do I know? I know theta's angle whose sine is negative 1/3. Remember, for the arc sine, you need to be between negative pi over 2 and pi over 2. And if I'm looking for the angle whose sine is negative, I'm going to be down here in quadrant number 4. Draw you a right triangle here. Go ahead and call that theta, this angle right here. Make you a 90. Now that's the angle whose sine is negative 1/3. So the sine of this angle should be negative 1/3. So I have negative 1 and I have 3, right? Now, how do we go about finding this? We use what? Pythagorean theorem, and let me save y'all some boredom here. Whenever we do this, we get 2 square roots of 2 for that value right there. Now, let's fill in. We have 2 times tangent of theta. What's my tangent of theta? It's negative 1 over 2 square roots of 2. Negative 1 over 2 square roots of 2. Over 1 minus tangent of theta squared. Well, we just said tangent of theta was negative 1 over 2 square roots of 2, so let's take that and let's square it down. All right, so if I multiply this 2 by this stuff, I get negative 1 over square root of 2 in my numerator. My denominator, I get 1 minus, and if I square this stuff, I get positive 1 over 4 times 2, right? Because if I square 2, I get 4. If I square that square root, I just get what's under it. So let's see, what does that give me? That gives me negative 1 over square root of 2 over 1 minus 1/8, right? That gives me negative 1 over square root of 2. Isn't this 8/8, really? 8/8 minus 1/8 is 7/8, right? Now what do? You multiply by the reciprocal. So you get negative 1 over square root of 2 times 8 over 7. So that gives us what? Negative 8 over 7 square roots of 2. Now what do I need to do here? Rationalize. So let's multiply by square root of 2 over square root of 2. We get negative 8 square roots of 2 over 7 times 2. Or I could say that is negative what? Divide that by 2, I get 1. Divide this by 2, I get negative 4. So I could say negative 4 square roots of 2 over 7 as my exact value there.